This instructional video details critical elements and considerations for the pull-off adhesion testing process. A portable pull-off adhesion tester measures the force required to pull a specified diameter of coating away from its substrate using hydraulic pressure. The major components of a pull-off adhesion tester are a test dolly that is adhered to the coating, a pressure source such as a hydraulic pump, a pressure gauge with a drag pointer, and an actuator for physically separating the dolly and the coating from the substrate. The Positest self-aligning dolly and actuator system enables uniform distribution of the pulling force over the surface being tested. It maximizes repeatability by eliminating the possibility of shear forces, which may result in one-sided pull-offs on rough and uneven surfaces. Pull-offs are always perpendicular to the substrate. Following a pull-off test, the breaking points, demonstrated by fractured surfaces, occur along the weakest plane within the dolly adhesive coating substrate system. The two most common standards for pull-off adhesion testing are ASTM D4541 and ISO 4624. The Defelsko Positest pull-off adhesion tester shown throughout this video is specifically identified in Annex A5 of ASTM D4541. Every Positest adhesion tester pressure system is calibrated and certified to a plus or minus 1% full-scale accuracy using a NIST traceable load cell. Several Positest models are available for measuring coating adhesion on a variety of substrates. A 20 mm dolly available with the M model is ideal for measuring on metal substrates. A higher resolution P model is available for expected pull-off ranges below 7 megapascals, 1,000 pounds per square inch. For masonry substrates such as concrete, the 50 mm dolly available with the C model is preferred. A more universal solution, the CM model, is available for customers with applications on a wide variety of substrates. Having selected the pull-off tester to be used, the next step is to identify a suitable adhesive for bonding the dolly to the coating. When selecting an adhesive, it is important to consider the expected bond strength and the nature of the coating and dolly. Specifications for most coatings are typically less than 1,000 psi. Thermal spray coatings are tested higher, though new standards quote acceptance levels at 1,000 psi or less. For applications under 7 megapascals, 1,000 pounds per square inch, or when a fast-curing adhesive is required, cyanoacrylates, superglues, are commonly used. When stronger bonds are required, it is recommended that a two-part epoxy be utilized. Several manufacturers utilize Araldite 2011 epoxy due to its versatility. Warnings: with any adhesive selection, it is important to test and ensure that the adhesive does not react to the coating, resulting in a change in its cohesion properties or bond strength. The goal of any adhesion test is to determine the pressure at which an adhesive between layers or cohesive within a layer failure occurs. To ensure pull-off tests are meaningful, preparation of the surfaces to be adhered is critical in facilitating adhesion between the dollies and coating. Lab tests have shown that for aluminum dollies and the Araldite adhesive, surfaces prepared with a 3M Scotch-Brite pad demonstrate strong, reliable bonds. Any residue generated by the dolly preparation method should be wiped away with a dry, clean cloth or paper towel. When preparing coating surfaces, the challenge is to prepare a clean surface that will readily bond with the adhesive without changing the properties of the coating. Each coating will vary, as will its preparation method. Preparation may range from wiping with a dry cloth to degreasing with alcohol to gently abrading to promote adhesion. When mixing two-part epoxies, it is important to follow the manufacturer's directions. Critical instructions include quantity of each part used, homogeneity after mixing, prevention of air bubbles, and staying within the working life. To facilitate the process, kits include all the equipment required for mixing. A single plunger application tube is used to provide equal parts of epoxy and hardener. A uniform coating of adhesive should be added to the surface of the dolly. When placing the dolly on the surface, it is important to push straight down to squeeze out excess adhesive. Twisting, rocking, or sliding of the dolly may generate undesired air bubbles. Excess epoxy should be wiped away from around the dolly without disturbing its position. Dollies to be placed on uneven, vertical, or overhead surfaces should be held in place with removable tape until fully cured. To prevent adhesive failures, it is important to allow the adhesive to cure per manufacturer's instructions. In some instances, the addition of heat may promote stronger and faster bonding. After proper cure time, the operator must decide whether or not to cut the coating around the dolly. As a minimum, any excess epoxy that appears during the curing process should be carefully cut away to prevent an increase in the pull-off area. A common method is the use of a cutting tool with an inside diameter matching the dolly size. When deemed necessary to cut through a coating to relieve unwanted lateral bonding stresses, the method utilized should minimize the induction of surface flaws such as microcracking. Such flaws may lower test results and create fracturing, resulting in partial pull-off results. For larger diameters such as the 50 mm dolly, a drilling template may be preferred. The final step is the performance of the pull-off test. Ensure the pressure relief valve on the pump is open. Place the actuator assembly over the dolly head. Attach the quick coupler to the dolly by reaching through the holes in the actuator assembly to lift the quick coupler. Release the quick coupling when the dolly head is completely engaged. Close the pressure valve on the pump tightly. Turn the red drag indicator on the pressure gauge to 0. Prime the pump until the black indicator on the pressure gauge starts to move. For optimum results, it is recommended to reach the pull-off target pressure in the middle of a stroke. Continue pumping at a maximum rate of 1 MPa, 150 psi per second, until the actuator pulls the dolly from the coating. Open the pump relief valve. View the drag indicator to record the maximum pressure reading. Mark the dolly for future qualitative analysis. An ideal pull-off test removes 100% of the coating from the substrate or particular coating layer. Anything less may require both quantitative and qualitative analysis. To conclude, the pull-off adhesion testing process is made up of several critical steps. These include the selection of an appropriate adhesive, preparation of the dollies and coatings, adhering the dolly to the coating, the dolly pull-off process, and the final analysis of test results.